A quick announcement quickly over here. So you should have received an email from me from the Moodle just about the guides for both of your written test next Tuesday and also the programming test the Tuesday after in about 2 weeks' time. And for your written test, tentatively, I still need to wait for confirmation from the departments. It will be 10 a.m. to 12 noon. That's voted by the most people, so I'll just go with that. I also personally prefer. That'll be Monday, September 30th, the day before your written test. Accumulate your questions, ask me, and then we got 2 hours to see how many we can answer. So that's for your benefits, okay? Just show up and ask questions. Okay, today we're going to continue with the topics about exceptions, and then hopefully we can also move to unit testing, okay? Let's see how much we can do, okay? But let's not rush too much. Let me review very quickly the two classes, the two examples we had. Let me just bring to your attention quickly. Why do we need exceptions? It's really about if you just want to do error handling using console messages, it's simply unacceptable even when things get easy. Okay? Let me just review this example very quickly with you. Let's say we have a circle class. When the radius is less than 0, what you're going to simply print to the console, say invalid radius. Okay? So now if you look at this particular main method, the tester over here, you can see at this point over here, we are trying to make a method call. And don't forget, we talk about caller versus callee. I assume you already understand the idea. So I'm going to say caller and callee all the time. So now in this case, we are calling this particular method setRadius, which is over here. So now at the point that we are trying to pass an invalid value, -10, because -10 over here, less than 0, is going to be true. So now it's going to print error to the console. So far, nothing wrong. However, what's really wrong is the execution flow of your program is going to continue. That's the problem. You can see even after the error has been printed to the console, we're still going to execute these two lines. That's the problem. The idea is, as soon as the error has occurred, somehow the caller must stop right away and have a way to actually handle the error. Okay? So now over here, this is when R is invalid, these two lines should not be executed. Should not be. Okay, that's really important. Okay, that's about something that's imperfect. It's not perfect in this particular case. So here we got only 2 classes. Let's see another example where we got 3 classes, the same issue. Let me just bring that to your attention. The second example we talk about, basically just similar idea, except that now we have caller and callee. It's slightly more sophisticated. So what we did was we tried to fill up this table over here last time. So remember this table here? We got the caller and we got a callee, right? That's what we did last time. You can review that part of the lecture. So now let's try to see what exactly we're doing. Okay, let me start from the top. Okay, from here basically. So now imagine that whenever we are trying to run your Java application, you have to run the class with the main method. So this is our starting points. Okay. So now let me just start with the green. Okay. Basically, we're going to execute this particular main method over here, and then as we go through the flow of execution, this is the line that we have to pay attention to, because this particular line is going to call withdraw from this particular bank class. So now we have a caller-callee relationship, right? So now the A is simply just read from the user. So you can see the A over here is simply whatever the user typed as input to the keyboard. Okay? So now, hypothetically, let's say, what if A is simply -10, which means I want to withdraw -10 from my account. That should be an error for sure. Let's see how the error will be triggered as a console printout. Let's see very quickly. Okay? That's something we did last time. So this is how you can trace your code. So something called call stack. Okay? Every time inside your method, entry point of execution, when you're trying to make a method call, you have to basically go another level. So the net level can be as many as necessary. In this case, we know that we started with bank application and main. So let me write it down here. So it's bank application dot main. This is how we started with. And then after this, we know that we're going to call this particular method, which is from the bank. So after that, we're going to go for bank dot withdraw from. Okay, I'll just say WF for withdraw from. Okay, so now once we call the method, that means we switch the context to this particular class over here, bank. Okay, bank, and then specifically we're calling this withdraw from. As we said, it's simply just going to withdraw from the particular accounts because the bank has an array of accounts. Okay, specifically, it's going to call this particular line where once we locate the account we want to withdraw from, we're going to call the withdraw method. So this is yet another method call. So let's write it down. So this one here, I'm going to use red. So this particular line is just going to be another method call. So we have our withdraw method and also the account class, right? So that means now we are going to just extend this call stack. So now it's going to be account dot withdraw. Okay, and now whatever value that was passed before, remember it was minus 10. So that means it's going to be minus 10. And this is going to be minus 10. So minus 10 is actually passed around between classes. So that's something you want to really get comfortable with. Okay, so now from this particular line, we're going to switch the context again to the account class. That's kind of the last class, the last layer. So now for this account class, since we are calling withdraw, so this is the method we're talking about, withdraw. Okay, once we get to that method there, you can see no more method call, just no further. So that would be the end of it. Okay. However, realistically, your method call chain might be as long as necessary. It can be 5, can be 6, can be 10. Depends, right? I'm just trying to show you an example where you got 3 different method calls. Okay, now we know that A is simply minus 10, and we know that minus 10 less than 0 will just be true. That means we're going to print out this particular error message, right? It will just be printed out. So this will be printed out to the console. Okay, so far so good. That means the error has been printed to the console. So the user should know about the error. However, following the same logic as we observe in the circle class, I want you to draw your attention to the next line. Let's go back to our, this is not a good color. Let's go back to our bank application class. Just remember, right? This is the method call we try to make over here. After that line, we have system.out.println, transaction completed, basically. You can see the pink one. So that means when we originally designed this particular class for bank application, we simply assume every time the withdrawal amount is simply just valid, it can simply just go through. However, in this case, it is not acceptable. I'll write it down. In this case, minus 10 will trigger console error. But this line over here will still be executed. But this line is still executed. So that means, as I said before, how do we judge whether or not your error handling is acceptable? Whenever there is an error happening, the caller must be stopped right away, and they should be forced to do something about it. But in this case, the caller simply have no choice. As soon as the error message was printed out from this line over here, it will still go to the next line without stopping. So that's a problem. Remember, the kind of execution flow I'm trying to show over here is simply just sequential. Okay? And once we introduce exception into the context, you will see that the execution flow will become a little bit not so ordinary to you anymore, but that's the right way to go. Okay? Anyway, so far I'm just trying to review the 2 examples. Remember this kind of context. If you only try to use console messages, it's not going to be acceptable from the caller side. You simply wouldn't stop the caller. Okay? Any questions about the 2 examples here before we move on to the exception? Okay, so now just about exception very quickly. What is really an exception? Okay? Well, it's basically an event that's going to happen at the runtime. And it's going to occur when you try, during the execution of the program, for example, when you try to set a radius or when you are trying to withdraw some amount. So now this term is really important. it will disrupt the normal flow. Just read it literally, and then I'm going to show you what does it really mean, disrupt the normal flow. You will see. And then when an error actually occurred, we have to actually, the method will actually throw an exception. For example, rather than printing an error to the console, we want to throw an exception. That's the difference when we move from without the exception to with exception. Okay, we're going to throw the exception, and now somehow this exception must be handled. And something I mentioned very briefly last time is a specify or catch requirements. So to handle an exception, you either have to specify or you have to catch, but we're going to review that. Okay, so now exception object actually contain different information just about what kind of exception we are talking about. For example, maybe the radius was negative or the withdrawal amount was negative, depends. Okay, and then, yeah, so also you will contain a little bit more lower level details, which you don't have to worry. Okay, that's about exception, what an exception is in general. It's a completely different way of handling error compared with console messages. Okay, that's the main lesson. Now, what I would like to go back very quickly was to Eclipse. Let's, because I'm also expecting you to play with the code a little bit. So if you go to the projects, I just call that exceptions to handle or not to handle. Basically, I'm trying to just show you three different versions where the exception was handled at different levels. When you have a chain of method calls, you may choose to handle the exception either in the first method call, or the second one, or the third one, basically, right? That's kind of the idea. You can have your choice. Let me review what we had last time, and then I wouldn't stay in Eclipse for too long, because that's something you can play with, okay? First of all, let's remember, first of all, you have the exception class over here, just called negative value exception. So that's something we create an extra class. So for this course, you don't have to worry about creating the class yourself during the lab test. If I really want you to do it, I will give the exception class to you. But if you want to program it for your own application, you should know how to create it. You can also use Eclipse to generate it. I also showed it to you last time. Let's say we have this particular negative value exception. Let's say that's what we have, okay? And then we have two classes. We have class A, and also we have class B. Okay, let me just go over very quickly what class A and B will do. Okay, I will go back to the catch. We'll specify a little bit later. Okay, I'll review that. So now we have basically three classes in the context, right? Again, we can, because we need a call chain to illustrate the story. First of all, we have class A over here, and then for class A, we have a method called MA. If the value you're passing is negative, we're going to give you an error. In this case, you simply throw a new exception. I just say error for now, just for simplicity. Okay? Otherwise, you can do nothing or do something else. The second class we have to use is over here called B. Class B has a method called MB, and that method is a caller for MA, right? You can see under the context for MB, we have to call MA. Okay? So you can see now the caller is B.MB. And the callee, in this case, is A.MA, right? That's kind of the exercise we did last time, okay? And then, of course, you have to be careful. For example, if I is somehow, for example, -1, this should trigger the exception to be thrown from this particular branch, right? From the MB, right? That's something just to mention quickly. Finally, we have this particular application class, okay, with the main method. And then inside the method, we're simply just trying to read some value just from the standard input, the keyboard. And then we are trying to create an object of type B, and also we are trying to make a method call, MB, right? So now you also can see what the caller and callees are. Okay, so now these are the kind of the setup. Okay, do a stack very quickly for you. You can imagine that when we try to execute this example, all the three versions will be identical. It's just about where to handle the error. That's something I want to illustrate to you. But the call chain will be exactly the same. So now, when we start, we're going to start with the tester, which has the main method. This is the entry point of execution. So when you think about the call stack, it's going to be tester over here, dot main. So this is starting points. And at this line over here, we're trying to call MB. Okay? That means we're going to switch the context to MB, right? In that case, it's now going to be B and then dot MB, right? And then we're going to have B dot MB. And then under this method, we're also trying to call MA. So that's another level of call chain, right? In that case, we're going to switch the context from there to class A. And then we have MA. Apparently, you can see at MA, we don't have any further method call, let's assume. So that's it. Okay, A dot MA. So that's kind of the call chain. Okay, don't worry about the 3 versions just yet. I'm going to illustrate it to you. Okay. Any question about the general setup for these 3 classes? Okay, I think the setup will be very similar to the bank, like accounts, bank, and also bank app. Very similar. Okay, it's really important for you to really to draw the call stack yourself, right? Just follow the sequence. Okay. So now we're going to see 3 different versions as to how we can handle the exception. The idea would be this part over here, we're going to throw. By the way, whenever you want to throw a new object, it's like a verb, throw, as opposed to throws. You would say throw new. Okay, we assume that we created this particular exception, so that'll be new negative value exception, right? And then with some messages over here. Okay, that's what we meant by signaling an error. So now the question is, where, let's say if I happen to be, for example, -2 at the runtime, how should we handle this particular exception? Okay, so now this comes to 3 different choices you can choose. Okay, so now, first of all, normally in the same method that you are actually throwing this particular exception, you don't normally handle the exception over there. That's just normally. So what we will do is, first of all, we're just going to say throws. So with S over here, that means this method may throw that particular exception. Throws negative value exception. Okay, that's how we started. Every version is going to be the same. So now, how many options do we have as to handling the error? Okay, let me show you one thing before I come back here. If we go back to Eclipse, I deliberately went back to this initial states. Let's say we have A, where we simply got, when I is less than 0, we simply throw new negative value exception. And also the method itself, say it might throw this exception. That's how we start with. Okay. Now, when we go to class B simply declare A objects and also say OA.MA. As we said last time, if you simply wrote it this way, it's going to complain, Java compiler, which means your code cannot be run. However, if you try to do this using console messages, your code will compile, will be okay. Because console messages is actually weaker than exceptions, but another story. Line number 7 is going to be some compilation error. If you move your mouse over, it's going to say unhandle exception type, negative value exception. So we haven't handled that yet. So now we have to go back to, quickly, how do you handle an exception? Basically, it's the so-called catch or specify requirements. Oh, sorry. It's either catch or specify. You have to choose either one. You don't choose both. Okay? What does it really mean to, let me talk about specify. Specify is easier. Basically, whenever you're trying to call a method, for example, let's just say withdraw. Eventually, we're going to give some exception over here. Whenever you're calling a method that might throw some exception, if I don't really want to do try and catch over here, alternatively, I can simply say my method itself, let's say withdraw here, simply throws this particular exception. That's option number 1. Okay? So this is specify as part of the method API, the interface. That's option number 1. Okay? What about the other option? The other option means I want to handle this particular exception. For example, you can see over here the catch solution. You can see over here we created a circle objects, and then we say c.set radius -10. Right? We know that this particular method might throw the negative value exception. Right? That's what we said before. And now, rather than saying the main method throws that particular exception, that's the option we don't really choose for. Okay? We can simply say try this particular line. If it does throw this particular exception, we're going to catch that and then do something about it. Okay? That's a very quick account for the two solutions here, either specify or catch. You don't do both. Okay? Having this in mind, we're going to go back to our A/B and tester example over there. Let's go back there. So what are the options we have? Okay? So now for version number one, because we know that this particular block in class A may throw the new negative value exception. That's what we know. That's how we start with. Version number one, we will try to handle the exception right here. Okay? Version number one, handle exception here. Okay, I'll show you the precise code in just a moment. I just want to draw conceptually for you. That's version number one, okay? Version number one is that. And what about version number two? Version number two, we do not want to handle at this particular class level. Version number two. Okay, version number two, I'm going to use pink. Version number two, handle in tester. That means we want to handle in the tester class. In that case, we have to make sure when we try to call this particular method over here, version number two, handle the exception here. That's version number two. Okay? What about version number three? Version number three goes to the extreme, which means I simply don't care about the exception. I'm basically going to specify the exception might be thrown throughout all the interfaces for the methods. That's what I'm going to do. Okay? Version number three is do not handle the exception anywhere. And version number three might be the easiest one to program because all you will see not a single try and catch block. All you see will be simply, besides every method, you will just say throws that particular exception. Okay? So now let's have a look of the three versions. And then what we got to do is we're going to try to get a feel about how things might go. Okay, let me just go back to Eclipse and show you something very quickly. Okay? So now, if you go back here, if you look at line number 7, we know that the exception is unhandled. The exception is simply from this particular page, negative value exception. So now, how can we do? Either we specify or we catch. What about specify option? Specify option would be besides the method, we're going to say throws. Negative value exception, exactly. That's a specify option. And did I get it right? Negative value exception. And negative, thank you. Sorry, I chose the wrong one for code completion. Yes, I was wondering about that. Okay, now that's a specify option. Okay, let me just undo and try to catch option for you. Okay, specify option will work. What if I don't want to specify? In which case, that means I want to handle it. Okay, I can say try this particular method call, which might throw the negative value exception, and then I can say catch. Negative value exception, okay, just give a variable name, negative value exception. Okay, and then you can do something over here, just do something. Okay, that will also be fine. So you choose either throws or you choose the try and catch, either way, not both. That's how we can get rid of the compilation error and make sure we choose either way, but not both. So now let me go over the three versions with you, okay? And then I'm going to leave from the Eclipse and then leave the rest to you on Eclipse, okay? Let's go back to iPad here. Let me explain to you how the three different versions are going to look like and then give you an idea, okay? Version number 1, okay? Let me highlight the important stuff for you, okay? Okay, version number 1. Basically, you can see version number 1. This is where the exception is thrown, and then for that, usually in the same class, we simply say throws that particular exception for that method. Okay, the same for all the three versions. So now, for the first version, we'll choose to do the try and catch in class B. That's the first version. As soon as you have handled that exception already, you can see in the tester over here, when you are trying to call this particular method, okay, you can say no exception handling is necessary. Because it's handled already. It's handled in B already. How do we handle that? Try and catch. A-L-R-E-A-D-Y. Okay, already. That's the first version. Okay? Guys, any question about first version? First version is simply that we may throw the exception from class A, but in class B, we simply do a try and catch. Okay? Version B simply means we're going to let B being a little bit irresponsible. It's going to say, now, even though I know that when I call MA, it might throw this particular exception. However, I'm simply going to propagate it to whoever is calling me. So what do I mean by that? Go to the second version. Okay, version number 2. Again, in class A, just the same. Throw that particular exception, and the method will just throw the same starting point. So now, have a look at what happened in class B. In class B, we don't have any try and catch, do we? How we handle that instead is by saying throws that particular exception. Okay? So we say handled by specify. So what does that really mean? The important consequence is this. The consequence is any caller of class B and B should handle this exception. Because now, as part of the API for MB, we would say that it might throw negative value exception. So anyone who's calling it must handle that. Okay? The same logic here. So now the story continues a little bit further. So now if you go to the tester and goes through the main method, right? Another level. So now you can see we created B, and also we have ob.mb over here. If I didn't have the try and catch, let's say, is it going to compile? If I didn't have it, if I just have ob.mb, the answer is it's not going to compile. Okay, let me show you. Actually, okay, let's say this. So now, let me just go to version B directly, version 2. Okay, you can download the source code and play around with that. This is set up for version 2. In class B, we simply say it might throw. Okay, sorry, over here. Throws negative value exception. Okay, we just choose the specify option. Now, let's bring the tester into the context. Okay, let's go to class tester. Let me create a new class. I'll say new class tester. And with a main method. Okay, I'm going to do the simplest one to show you. Okay, let's say over here, we're just going to say B, object B, object is new B over here. And now what I want to do is to say o.mb and then give some integer value. Okay, so now the integer value can be read from the user. So I can say scanner, and then input is new scanner. Okay, and then I'm just going to read from the keyboard, system.in, for example. Okay, so now I'm going to pass the input from the user. I can say integer I can be anything read from the keyboard. Okay, next int. Okay, that's I. And now I'm simply going to pass I. Now, line number 11 did not compile. So that's exactly the question I just asked you in the iPad. I said, what if I got rid of the try and catch from over here? Just ob.mb alone. Is it going to compile? Some of you wouldn't believe that shouldn't compile, but I'm showing you it will not compile. Go back to Eclipse. If I simply have that, what kind of error message should we give? You want to take a guess? It's all about the exception being unhandled over here. If I move my mouse over, it would say, on handle exception type negative value exception. Okay, that's what it is saying. The reason is the callee over here is MB. Agree? Is MB. Okay. Callee is MB. And then if I go back to MB, what do I see? MB itself says in as part of its method declaration, it throws negative value exception. That means if you're trying to use MB, you better handle that either by specify or by catch. Again, every time you're trying to call a method in your class, if as part of the method's API, it says throws a particular exception, now the caller has only two options, either to specify or to catch, right? That's the requirements. That's why I want to show you the three versions. So now let's go back here. If I go back to the tester over here, I got two options. Well, I can either say specify or I can say try and catch. Typically, the main method is really the last level you want to handle the exception. You wouldn't typically say this. I would say, if you only say throws negative value exception. Sorry, not here. Be careful, when you say throws, it should be besides the method, not the class, right? I just made that mistake. Besides the main method, I may say throws negative value exception. Everything still compiles. However, this is very odd. Typically, for the main method, you should really handle the exception. That's the last level you can delay the handling. That's the last level. Remember, we didn't handle that in class B, so we propagated to the main method. But now, if we chose not to handle that again, that's not a common practice, even though you could do it. So now, what's the consequence of this? Let's try. If I simply say this particular main method might throw negative value exception, that means nothing is going to handle over here when the negative value exception is thrown, right? You'll be thrown to the console. So let me try that. Okay, let me just go into execute it for tester. If I simply try, oh, you know what? Let me just do something here. System.out print line. Okay, I say enter an integer. Okay. Okay, system.out print line. That's good. So now let me say run, enter integer. If I simply say -2, for example, that's negative. So now I would expect -2 over here is going to trigger a negative value exception eventually, right? So now if I simply hit enter, you can see that over here. Okay, let me show you that. That's really important to see, observe. Exception, negative value exception has been thrown to the console directly. So that's not good. You will never ever want your user using your program to see an exception on the console. That's the worst thing you can do. Okay? However, it works, I mean, in terms of compilation. What we can do is try version number 2, which I wiped out previously. So version 2 over here simply shows you, now I might say in the main method over here, I'm simply trying to catch that. Okay? So now this may throw negative value exception as we observed from this particular declaration over here, right? So now we can just do try and catch and try to do something about it. Okay, that's version number 2. Okay, let's now go to version number 3. Okay, question? Yes, please.
In both of the first versions,
you mean the first 2 versions? Yes.
In class A, why are we specifying a throw there if we are going to be using a try?
Okay. Okay, so good question. You're basically wondering about class A, right? Okay, let's look at that. By the way, for all the 3 versions, class A is really the same. Okay, let's pay attention to 2 things over here. Number 1, if you look at, first of all, throw new negative value exception. Okay, so this is, okay, sorry. So this is where we signal the error. Okay, that's how it started with. And typically, you don't do the try and catch in the same method, because that's the very first place where it is the exception occurred. You want to actually somehow propagate this particular exception, in this case negative value exception, to whoever is calling MA. You want to propagate just one level. Okay? You wouldn't want to do try and catch it right here. Okay? Yeah. And then that's why we say throws this exception. That means whoever is calling MA, they have to handle this either by specify or by catch. Okay, yeah. Okay, guys, before I ask if you have any question, first of all, exception is quite a confusing and challenging topic, I agree. But try to see if you can get the most out of the lecture, try to study the slides. Okay, I think the slides, hopefully now you can follow more or less. Let me just give you a very quick recap of this particular example. This is really the easiest one for you to really see where in the call chain can you actually handle the exception, okay? So now what I want to do is, version number 3, by the way, again, for version number 3, we have throws. Let me use red. We say throws over here, and also we say throws over here. You can say basically just throws, no try and catch. Version number 3 is the easiest one for you to write as a programmer, but it's the worst, okay? Worst. Okay. Basically, the 3 versions I've just shown you, okay, when you study for this particular slide, I want to reflect yourself. What we are trying to learn over here. You're learning about 2 keywords, okay? Basically, throw versus throws, okay? Throw is when you want to signal an error. To say something bad occurred, I want to throw the error right away, okay? Throws means to warn any potential caller that they must handle this error. Okay, that's the difference between throw and throws, and then we may do this in different places, okay? You should not see throws and also try and catch at the same time, either specify or catch, either way. Okay, any questions, please? Yes?
So why is it bad to have an exception message on your main method?
Oh, I mean to have the exception thrown to the console?
Yeah.
Okay, think it this way. Let's say you are a very good Java programmer. You try to develop some library for me, for example, array list. I know nothing about Java. All I know is how to try to make a method call, create new objects, and just try to use your array list. So whenever I'm trying to use it, me as a client or as a user, I never actually want to see anything that like this. You can see if the main method actually simply throws that particular exception, which means the main method didn't handle that. In that case, I would simply see this on the console, or my program just crash. I can do nothing about it. You as a programmer in your library, you should have used try and catch somewhere in your call chain to actually handle that, not me as a user. So that's why we said in the main method, typically, that's the last part you want to do the try and catch, rather than simply throw the exception to the user. Yeah, it's more like a design issue. Yeah. Yes?
So while there's 2 ways to deal with the exception, just to specify or catch.
Correct.
Catch
Yes, so remember the catch was specified requirement telling you have 2 options, right? We know that it's definitely not good for every caller to simply throw the exception, because it's not very responsible. As long as you can make sure throughout the course of the call chain, somebody actually try and catch, that'll be okay at some points. So at which point it's more like a design issue. That's not something we are trying to address over here. Okay? Yes?
Can you try and catch for multiple exceptions given that a method throws multiple?
Okay, so the question was, can we have multiple catch block, basically? That's what you're asking. Yes. However, depending on, actually, we'll get to one example, okay? Yes, we'll get that. Yeah, let me just save that explanation. We'll get to there. So the brief answer is, yes, we can definitely have multiple catch block. If the lines of code you're trying to make, they simply got multiple possibilities of exception throwing. In that case, you have to have multiple catch block. We'll see that. Okay, okay, so now I want to explain another very important concept to you. So now we are going to depart from this particular simple example. And let's go back to our circles class, okay? We just use that. And then for the bank class, it will be something very similar. For that, I can leave you to study, right? So now let's, again, try to revisit the circle class, okay? So now in the circles class, okay, so now we are trying to do exception. Let's assume that we have already created this new exception, just called it invalid radius exception, when we pass minus radius, let's say. Okay, so now the only change you can see from the circle class is, you can see if the radius I'm passing is negative, now rather than printing to the console, I'm saying throw new invalid radius exception. And then because that's where I signaled the error originally, I'm just going to put besides the method here to say throws invalid radius exception. What's the consequence over here? The consequence is whoever is calling this particular set radius method, for example, the main method, they have to handle that by either specify or catch, right? So now let's see that. Now, if I simply go to this particular class over here, okay, so now circle calculator 1, okay, and then we have the main method over here, and then we created a circle object C, and then we try to call this particular method here. If I didn't have the try and catch, and I didn't have the throws besides the main method, I would get a compilation error message, like what we have seen. Okay? Now, since I've chosen to try and catch, that simply satisfies the requirements, so I'm okay. Okay? I'm basically surrounding this particular method call by try over here, which means I'm going to try this particular block of code. If any time some kind of exception is thrown, it's going to try to match by the catch block. So now let's make things a little bit easier. Let's say there's only one possible exception that can be thrown, the invalid radius exception. If the exception happened, we're going to go into the catch block and then do something about it. Okay? So now this is a great improvement from the console messages, because in the case of the console messages case, you can simply write these lines of code without thinking about how you can try and catch it, right? Or try to throw it, right? So that just adds an extra consideration for you to do. Okay, that's about the coding level. We need to do some trace very quickly. Okay, any questions? Okay, let me trace on iPad first together with you, and then if time permitted, I'll try to do Eclipse as well. So there are two cases basically. Okay. Now let me just wipe out this particular -10. Okay, I want to try two values for you. Okay, let me write it here. Let's say case number 1, valid radius 5. That's definitely valid. Versus case number 2, invalid radius -4, for example, right? Case 1 and case 2. Let's do case 1 first of all, okay? Because I really want you to see the execution flow. And remember, one of the phrases I mentioned, exception, if it ever occur, is going to disrupt the normal flow. I want to illustrate it to you. Okay? So now let's try that. Case number 1, if we put 5 over here, let's say, okay? So now let's think about what lines will be executed. First of all, we're going to execute every line outside the try block, right? We're simply going to create this particular C of type circle, right? And then we go into the try block over here, and now we're going to call C.setRadius. So that means we're going to call setRadius, in this case it will be 5. Now we're going to go into the else branch, don't you agree? Right, 5, because 5 less than 0 is false, so that means to go to the else branch. And then we're simply going to set radius to be R. Agree? Okay? No exception. No exception means continue with the sequential flow. So that means after that we go to the next line, and then we set the area to be whatever that should be, right? 5 multiplied by 5, and then pi. And then we print it out. So far, these are the lines we have executed. And then we go to the end of the try block. And then since we have reached the end of the try block, that means no exception has been thrown throughout the course of this block. And then we're simply going to bypass the catch block. And then go to the end of the method. That's the green one. That's the normal flow of execution, almost the same as if you didn't have the try and catch block, right? Guys, any questions? That's a normal flow. So now, let's think about what the disruptive flow will be like. We'll see much more complicated example today, right? I just want to get the basics right. So now, let's try this case number 2. Let's try -4, okay? I'll put -4 over here instead, okay? Again, let me put on the right-hand side, okay? First of all, we're going to execute this line also, because that's outside the try block, which is common to other cases. And then we're going to go to the start of the try block, and then we're going to do c.setRadius, okay? And then that means we're calling this method here, but it's not -4, right? -4 less than 0 will be true. That means we're going to have this particular exception thrown to us. Agree? Because in this particular method, it simply throws it. So that will be propagated to the main method. So that means from here, it will, the invalid radius exception will be thrown. Okay, that's really important to realize. So now, here is how the normal flow of execution might be disrupted. Rather than going to the next line, rather than doing that, we're now going to skip the rest of the try block. And then go to the catch block. Let's assume we only have one single catch block. Let's assume. Okay, catch block. And then the exception being thrown, invalid radius exception, simply matches this particular exception we are trying to catch, right? It matches. So now we'll go into the catch block and execute line by line from there. Okay? And then that one is only involved to maybe give a little bit more printout of the exception object itself. And then after that, we simply, we finish the catch block and then go to the end of the method. That's a red one. Okay, to do a visual summary for you. In the case of the normal flow, this is what we have. Execute this line, execute this, because no exception has been thrown, so we continue with the rest of the try block, and then skip the catch block. That's it. That's the normal flow. What about the exceptional flow? In that case, we still try to execute outside the try block, and then we still try to execute this method, and now because exception is really thrown, so we skip the rest of the try block. And then we go to the catch block, and it matches. And then we execute whatever that's inside the catch block, and then go to the end. These two floats must be very well understood by you, okay? Because every time we talk about using, for example, exceptions to maybe do some test cases, either in console tester, which we'll talk about today, or to use it for JUnit test, you have to be comfortable with both, okay? Any question about the two different flows? One is normal flow, just going sequentially. In other flow, as soon as the exception is thrown, it got disrupted to the catch block. Guys, any questions? Or you can ask me again in the review session. That's also fine. You might need some time to think about it. Okay. Okay, that's about the this. Okay. So I guess I'll skip the part for the Eclipse. I'll just go ahead with the rest. Okay, so that's about the exceptions. Okay. And then you will see that in the slides, I gave you a little bit exercise over there. Okay, let's just go there. Okay, let's try or specify. That's the number one important principle for exception, either catch or specify. Okay, so these are the three versions that we talk about. Okay, I'll leave the rest to you. I already explained them. Okay, you can go over them. Okay. By the way, this is simply just a visual summary of the call chain, right? I'm just trying to give you a little bit more information about how the method is being called in the chain, right? That one you can look at that. Okay, so that version 2 also we talk about. Version 3 we also talk about. Okay, and then the one we just talked about was how to apply exceptions to circles, right? That one we'll also explain. Okay, so that one I can also go over. Okay, that's fine. Okay, so now a little bit exercise for you. Okay. I would say, I'm going to show you the example very quickly anyway, but I want you to think about this particular one, because I think that one is also covered by one of the practice questions I gave to you in for the lab test. Okay, you can try that as well. Okay, think about what we are trying to achieve over here. basically you want to say, rather than setting up the radius over here just by just trying a different input like a 5 or -4, is it possible to actually prompt the user iteratively for some radius? Is it possible? Okay, that's a question. For example, let's see this. I'll just show you the concept and I'll run the program to show you. Let's say every time if the user tries to enter something that's negative, your program, rather than throwing some exception to the console, which is bad, right? One of you actually asked me, why is it bad to actually throw exception right away to the console, right? You want to have a very robust application like this. Okay? If the user enter -5, rather than throwing the exception to the console, you simply prompt it again for the value. Okay? They tried it -1, also not good. As soon as they have a valid value 5, now you can calculate. Okay? Basically, you're going to iteratively prompt the user for input as long as they are not valid just yet. Okay? That's kind of the idea. Okay? That's kind of the exercise. Okay? I'll show you very quickly, and then I'm going to point out to you why you should really pay attention to in the solution. Right? We don't have to spend too much time on this. Okay? Now, if you go to, for example, under exception, circle and bank, and then there'll be circle with exceptions. And then I want to go to circle calculator 2. Okay, that one there, you can see I'm trying to use a while loop. I'll point out the critical thing for you in just a moment. Okay, and then if I simply try that, enter radius, if I say -1, you see, it simply tells me application is still running, it hasn't crashed, but it tells me try again. -2, well, it still doesn't give up, right? Now I say 10, now I'm okay, it calculates for me. Okay? That's kind of the simple application you can think about, right? By using exception handling. Okay? Now let me go to the solution over there. Okay, and I want to point out some critical thing for you. Okay, that you can look. Okay, I'll go to the actual code in just a moment. But remember, we actually got this exception class. We got this exception class, and also we got circle, which might throw this particular exception. Okay. So now the console, the tester over here that we have is a little bit different, okay? Basically, what I have added was a while loop. Okay, I will talk about this in just a moment. And then inside the while loop, I have basically every time I say prompt the user for a radius, and then read the radius from the user, and then create the circle objects. And now, in order to set the radius, because set radius may throw this particular invalid radius exception, because of that, I need to choose either specify or catch. Because now I'm in the main method, I shouldn't choose the specify option, in which case I'll throw the exception to the console, which is bad. Okay? So now, I'm simply going to wrap this particular method call around try and catch. Okay? The one I highlighted in yellow is how what makes the while loop work. Okay? Basically, what I did was I simply declare a Boolean variable here. I simply say input radius is valid. Let's say initially simply just false. Let's say, and then I would say as long as, by the way, you know what this is, right? It's negation, right? As long as the input is not valid, I'm gonna stay in the loop and keep prompting the user, right? As soon as you can see, as soon as, question for you, as we said before, let me put a question over here. If we are able to move from, can I just call this line 1, okay? Let me call this line 2, okay, line 1 and line 2. If we are able to move from line 1 to line 2. What does it really mean? Okay, say that again. No exception. That's exactly right. Okay, let me say that again, right? Because we know that line number 1 here has the potential to throw you the invalid radius exception. If it was thrown, the normal flow will be disrupted. You go to the catch block. If you can survive to the next line, that means exception did not occur. That's a very important logic. Okay? If you're able to move to line 2, that means now the input radius is simply valid. Set it to true, this will help you exit from the loop. Okay, that's the essence for the loop I want to show you. Okay, if you're having trouble to trace this code, I do have 2 test cases for you over there, -5 and 10. Give it a try. If you're having some trouble, talk to me, or you can ask this in the review session. Okay. Any question about this so far? I'm just showing you another example where your try and catch block can be usefully wrapped within a while loop. That can really help you create some very useful application. Okay, not just a single execution. Questions, please. Okay, I assume everything's okay. Okay, after this, let's see what else. Okay, and this is just another, so basically the next few slides, we're just revisiting the bank example. For that one, I don't need to bother you. The same logic apply. Okay, for that one, I'll leave you to study for that. Okay. Okay. Also, the slides is self-contained. Let me know if you got issues. Okay, so now let me move on to the next topic quickly about exception. We're getting there. Okay, so you will see that there are maybe 1 or 2 more slides just to make everything we have said, everything, the way I've explained things just by using example code and also try to use some Eclipse and also use some tracing on the paper. So now the slide will simply make things a little bit more formal. So hopefully now you can see a little more clearly how things go together formally. Okay. Okay, basically we always start with the main method for sure, and then you may have a chain of method call, right? Eventually the exception might occur, in which case you have to handle that at one of the callers. Okay. Okay, and also we got something called call stack, right? Okay, for example, this is a call stack that we talked about for the bank example, right? Nothing new here. Okay, that's just a visual view of the call stack, right? You got the main method, which calls another method, which calls another one, which might cause another one that throw the exception. In which case, you have to handle the exception somewhere. Okay, that's just a general view. Okay, so now, finally, this slide here just summarizes everything about exception in English words. Okay, I'll just go over in about 2 minutes to help you. So when you study that, hopefully it's not too bad, right? That's the whole slide, right? Kind of complicated, right? I'll just highlight some issue to you, okay? So now let's just use the example about A, B, and tester, right? After a method throws an exception, the runtime system searches the corresponding call stack. Well, what is a call stack? Remember the way we did it before, we simply call tester.main, which calls b.mb, and which calls a.ma. That's kind of call stack we had, right? It can be true. It will be similar cases for every application. That's a call stack, okay? And then let's go on. And we see that this block of code, and contains a block of code to handle the exception. Let's say if a.ma throws a particular exception. So now you have to handle either b.mb or tester.main. Either way, right? You got to handle it either by catch or specify, okay? Something called exception handler, okay? So now, basically, if the exception cannot be found from the call stack, which means if I didn't try to handle in b.mb, I also didn't try to use try and catch in tester.main, that's the worst case. You will simply be thrown to the console. Okay, that's the worst case, right? You'll be thrown to the console. That's the worst case. Yeah, you can just read the text. Everything has been demonstrated by using examples already. Okay, I guess we got a little bit more examples for you, and then we can move on to testing. Okay, more examples. And this goes back to one of you guys' example to me about 15 minutes ago. Can you have multiple catch block? The answer is yes. Let's consider this. Let's say we have a bank objects, and then we simply add account into the bank, right? Remember, new expression here is anonymous objects, right? And also, let's say we try to deposit into the bank, and also we try to withdraw. And now, when you review the example for withdraw, it can throw invalid transaction exception. For example, if A is negative. So this green line here may throw a particular exception, okay? And then we have another line. We just try to create another object, circle C. And then we try to set the radius. And now remember, set radius may throw another kind of exception, which is negative value exception. So now the green and the red are in the same try block. That means there are two possible exceptions that might be thrown from this try block. Agree? So now what we have to do is to catch them separately. How do you catch them separately? Well, have different catch blocks. So you can see that over here. One is catch if somehow this particular line throws a negative value exception. Catch that and then do something about it. Otherwise, if this green line here, withdraw, throws the invalid transaction exception here, do something about it, right? In this case, the order of the catch block doesn't really matter because the two exception classes have nothing to do with each other. So you can switch the order, okay? Once we talk about inheritance later after the reading week, I will try to see if we have time to go back. There is a way to catch all the exceptions of any kind, but we don't have to worry about it. For now, all you have to do is, when you look at this particular try block, for example, in the test, I might simply give you this try block. I would say, look at this particular try block. How many catch blocks do you need to catch the exceptions that might be thrown specifically? 2, right? In the green line, one kind. In the red line, the other kind. Okay, 2 catch block. Okay, that's just one more example. Okay, another one which is also very useful. Okay, I want to point out this to you. Sometimes when you are trying to program your own application, you may want to read a string value from the user. Okay, for example, I'll tell you what the application. Do I have any example here? Okay, yeah, let me just write it down. Because basically whatever you read from the user can just be a string. For example, if you read from the user, let's say, for example, if the user simply give you the string literal 2, 3, okay? That's what the user typed from the keyboard. Basically, you can think about everything that's typed from the keyboard is simply a string of characters, okay? If you got 2, 3 here. Now, how can you, for your program, to turn this into the value 23? So this is a string, and this is an integer. How do we do that kind of conversion? Okay, and in order to do this, it is also a standard way of doing this. I want to show you quickly. Okay, using exception. Okay, and the background knowledge you should get is in the integer class in Java library, there is a method called parseInt. Parse means to analyze the whatever string objects you give as input. You want to try to parse it, okay? And then you want to return integer back to it. For example, if I say, okay, I'll show you an example. If I say integer, oh, by the way, static, right? That means we don't need the context objects for that. If you say integer, the class name, the parseInt, quote 23, you will return 23, right? It's possible. If I give, for example, 23 over here, you will give you an exception, right? We've got 2 cases, right? So that means they have parseInt and throws number format exception. So now everything seems familiar to you. We have a method that we may want to use, and that method, as part of its API, says throws a particular exception. So now by using a try and catch block, we can distinguish between the 2 cases. Either the normal flow, the exception does not occur, or the abnormal flow where the exception does occur, right? 2 cases. So now, let's see what kind of code can we write. That's the last example for exception. So now, the question is, you can also give a try yourself. We want to write a fragment of code that will prompt the user to enter a string. Okay, you can use the next line method from scanner. And that's going to represent an integer, for example, quote 23 quote. Okay? And now, if the user input is not a valid integer, then give them some error. Otherwise, you can convert that into an integer, right? That's a problem, okay? Here's the code. Okay, let me just switch to iPad and show you quickly, okay? That's the multiple catch block we just talked about, okay? So now, this is the code, okay? Again, we have while loop. We have also try and catch, right? Everything very similar programming construct, but for different useful application. Let's just go over that very, very quickly. So now let's see this. Okay, we have a while loop, and then we simply use the Boolean variable as we said before, right? Try to see if the user enters something that's valid, okay? So now we say, first of all, enter the integer from the user, and then try to read something from the keyboard. Okay, it's just a string. Okay, notice that it's a string, user input. And now what we do is we have a try and catch block. A very similar question for you. Okay, I want you to pay attention to this line specifically. Okay, specifically the right-hand side. You can see over here, we are trying to make this method called integer.parseInt, which might throw number format exception. Same question as before. Let's say this is L1, this is L2. If we are able to move from L1 to L2, what does that really mean? No number format exception, the same logic, thank you, right? So if you're able to move from okay, let me say this. So if I'm able to from L1 to L2, means there's no number format exception occur. In which case, I can simply say, oh, the user just entered a valid integer. So I'm going to set this to true, and it's going to cause the condition here to be false, so I can exit from the loop, right? Otherwise, if I could not go from L1 to L2, that means the flow was disrupted. I got to go to the catch block and do something about the exception handling. Okay, that's a very simple fragment of code. And do expect to write something like this, or to read a code like this. Okay, okay, I think that's about everything about exceptions. Okay, I think I tried to give you everything you should know as a Java programmer about exceptions, but you got to study for that and ask me questions. Guys, any high-level question or anything you want to ask about exceptions? And then we can move on to the next topic for about maybe 15 minutes, maybe less than 15 minutes. Questions, please. Are we okay? Okay, my best advice, study for this and approach me for questions. Okay? It's not easy. Not easy. Okay, so now let's talk about, I would definitely talk about JUnits. That's definitely required by the course. However, I do want to give you a little bit more general story about why we want to use a framework like JUnits to do your testing, as opposed to console tester, which is pretty much how you would do it, maybe back from 1022. Okay? It's always important to understand why we are doing things this way, as opposed to the old way, right? You don't want to just accept whatever I say. Okay, I call it test-driven development, but I'll explain TDD maybe on Wednesday when we get there. But today, I am going to show you basically some example again. It's always good to show by examples, and then we'll see how we can test things using exceptions, first of all. That's also a nice review for exceptions. Okay, so now let's use a very easy example. First of all, let's assume we have two exceptions over here. One is called value too large exception. The other one is called value too small. Basically, what we're going to have is we're going to have a single class called counter. And the counter value might go from 0, 1, 2, and 3. So these are the only 4 possible values for a counter. If your current value is 0, you should not be able to be decremented to -1. Right? That'll be value too small. If you're already in the maximum, which is 3, you should not be able to be incremented to 4. Right? That's value too large. That's the idea. Okay? We're going to see. We've got two kinds of exceptions here. You can assume that's given to you, okay? And then we have to remember the catch will specify requirements. We're going to see that, okay? So now, either you have to specify throws, or you have to catch in the try and catch block, okay? That's a very quick review. Okay, let me just go there. Okay. So now, basically, a very quick review about specify or catch, right? Basically, whenever you try specify, that simply means besides the method, you simply declare throws. Okay? Throws. And also, if I'm trying to call a method that might throw this particular exception, I can also choose to just say throws. Okay? That's the specify option. Okay? Nothing new. What about try and catch? So now, if I'm calling this particular method over here, M2, which throws this particular exception, now I might choose to try and catch, try to handle that over here, rather than propagating further. Okay, again, catch was specified. Okay, quick review. So now what we will do is let's talk about counters quickly, and then we'll see test cases. Okay, so now let's talk about counters. Let's say we have a classical counter, and then we have final. You have seen that in 1022. Final means it's a constant. The value once set cannot be modified. And static means it's global, right? By the way, there was a clarification I made on the course forward about static versus non-static. Please make sure you read it. I also added slides for that. Okay? So we got maximum value and also got minimum value. Let's say between 0 and 3. And then we have also integer value, and then also we try to initialize a value to be minimum. So all the counters objects start with the value 0. Okay? And then we can also get a value. Okay? Okay, more later. Okay, so nothing, okay, the important requirements is over here. The counter value must be between its lower bound, which is 0, and the upper bound, which is 3. That means every time when you're trying to do increments and decrements, you better be careful, okay? So what do I mean? Question for you. When we try to do increment for a counter, what should we watch for? Increments. Yeah, so if the counter value has already reached its maximum, in which case we should not allow to increment further, right? In which case we gotta throw an exception instead, right? Symmetrically, if we are trying to do decrements, if the counter value currently is simply just 0, the minimum, we cannot decrement further, right? We should throw an exception, okay? Yeah. Okay, so now, exactly, okay? So you should not increment above the maximum, you should not decrement below the minimum, right? Easy. So now let's complete the counter class. Let's say for the increments, by the way, there's a correct implementation, but we're gonna play with that a little bit later. We say that if the current value is simply just maximum, in which case it's 3, we should not allow to increment further to 4, which is not allowed, right? We say if the value is simply counted at maximum value, we throw new value too large exception, right? Straightforward. Otherwise, we try to increment the value, right? Symmetrically, when we try to do decrements, if the value is currently equal to the minimum value, which is 0, we should not allow that to decrement it to -1, right? So we throw new value too small exception, and then otherwise we do decrements. Any question about these two methods? Very easy, but that will illustrate many points, as we'll see. So now what we're going to see is we're going to see how we can test this particular classes. Let's say this is something that your colleague in the same team gave to you. You want to know whether it's safe to use, so you want to test it. How would you test it? Okay? Of course, assuming that you haven't learned JUnits, otherwise JUnits will be the right answer. Let's say you didn't learn about JUnits, the best you could do is by using console. Basically, you're going to create counter objects and simply say maybe c dot increments, and then system out the print line, the counter value. That's the best you could do. However, even that, let's try that to illustrate and also review exceptions a little bit. So now let's go over some concept with you together. What do I really mean by a test? So later on, in your lab test, you will be given certain tests to start with, but it's recommended you also try to write some tests by yourself. So let's learn how we can write tests. What's the components of a test? Test simply means I have some ideas about how this method should work. So keep that idea as an expectation. Run the code and see if the actual output produced by the program will match my expectation. Okay, it's documented in the slide, don't worry. Let's see example. Basically, you want to manipulate the relevant objects, can be bank, can be counter, can be circle, right? For example, you simply initialize a counter object C. C is assigned to new counter. And then you simply say, what's going to happen if I say c.increments? Because we know that every counter object when initialized got a value 0. In this case, incrementing it should get value 1, right? From 0 to 1. I want to make sure if this part is going to be according to my expectation. On the other hand, what's going to happen here? Another case, if I initialize a counter object with value 0, and I try to call decrements, what do I expect to occur? Exception, right? Because in this case, C.getValue for the red is simply 0. I should not allow 0 to be decremented further. So for the green, I expect no exception, and the value should be 1. For the red, I do expect an exception. So exception in this case is something I want to test whether it should occur or not. Okay, that's something that's a little bit new conceptually for you, but we're just still trying to use exception. Okay, so now green and red, and now what do you expect to occur? As I said, for the green one, since there should be no exception thrown, so value should be whatever the minimum is, which is 0 from 0 to 1. Okay, that's a normal case. What about exceptional cases? Now in the red, because I try to call decrements when the value is 0, so that should give me value too small exception, right? Two different cases. And also, what does your program actually produce? What do I expect it to produce? So now, in the green one, I simply call C.getValue, trying to see if the value is really 1, right? That's one way to do. What about the red? The red is a little bit tricky logically. That's something I want to explain to you. Basically, the idea is if I try the red test case, if the value too small exception is really thrown, that should be considered as a success. If it was not thrown, that should be considered as an error. That's the funny part, right? Because you're expecting some exception to be thrown. If it is thrown, it's considered success. Otherwise, it's an error. Okay? Everybody clear? Okay, in general. I'm just trying to make say things a little bit informally before we make it make some code. Okay, every time when you have a test, you will pass if the outcome that you expect to see really occur. You will fail if it does not occur. So this slide here basically summarizes all the components of a test. The green and the red tells you sometimes you do expect something to actually to be produced. Red part tells you you're expecting some exception to be thrown so that the error handling is working well. Okay, green versus red. For the green, it's rather easy. I wouldn't bother you too much. I want to talk to you about the red. The red is going to be interesting. Okay, and remember we talked about that when you have exception, the try and catch block in the place, you got two possible flows, either the normal sequential flow or the disruptive flow is going to be applied heavily over here. Okay, we're going to see. Okay. Do I have 2 minutes? Okay, 2 minutes. How about that? Okay. I want to show you just one block of code very quickly. Okay, we got a classful counter, and now I want you to look at just this code here. Okay, I'll just do 2 minutes, very informal talking. Okay, and then I'm going to ask you to read this before Wednesday, and then Wednesday we can finish the whole J units. That's the plan. Okay. So now I want you to just focus on this class over here, right? Okay. Since I got 2 minutes, I would suggest give you 30 seconds, only 13 lines of code. Can you just read it through? First of all, 30 seconds, and I'll take 90 seconds to explain. Okay? Okay, another 10 seconds. At least you know all the ingredients that we talk about. We got try and catch, we got method call, and also we got object creation, etc. Okay, let's have a look. Now, let's see this. Basically, first of all, I'm creating a counter object called C outside the try block. And then for now, I'm simply going to print out system out the print line. What's the current value for C? That should be 0. Agree? Okay. And then I'm trying to call C.decrements. And now, question for you to ask yourself, why do I have to wrap this particular method call around the try and catch block? Because the decrements, if you look back at the declaration, it throws value to small exception. Okay? And then you can see that right after this particular line, I want to put 2 lines that I want to draw to your attention. The first line is over here, green one, and also the pink one. Okay, and then I want you to look at the method call. Okay, I want to discuss this quickly. Okay. Now look at line number 6. we know that line number 6 has the potential to throw value to small exception. Agree? So now, do we expect an exception to occur from line number 6 in this case? Do we or do we not? We do, because from here we know that c.getValue is simply 0. And you try to do decrements when it is 0, we should expect value to small exception to be thrown. If it is thrown, should we go to green or pink? If value to small exception thrown, go to green or pink? Green, thank you. Disrupted, if it's thrown as expected, we say success. Otherwise, if we simply go from this line to this line here, that means it was expected to be thrown, but it was not thrown. In that case, we say error. Do you follow the logic here? Let me say that again, and then I still see people being honest, knock their head. Let me repeat again, and then we'll continue on Wednesday, okay? Basically, we're saying this. This line over here has the potential to throw value to small exception, right? Now, if we are able to go from this particular line to this line, that means the exception was not thrown. That means we just go with the normal flow of execution. However, because in this case, decrement, when value is 0, we do expect the exception to be thrown. So if you're able to go from here to here without the exception being thrown, we should consider that as an error. On the other hand, if the normal flow got disrupted because of this particular exception that we expected, that should be a success. Okay, good. Review this example here, and then we'll continue from here on Wednesday.